Hey folks, today's topic, we are simplifying trig expressions. So this is the lead-in to the bigger idea, which is verifying trigonometric identities. In other words, I call these trig proofs. So you're going to take a statement and you're going to try to prove. They're going to give us a statement like cosecant of theta, sine of theta equals 1. And we're going to try to prove that using algebra. So to be able to do that, we have to understand that there are some tricks and some things that you should be looking for when it comes to trig expressions. So let's go to our unit circle and let's add a couple of things. So I ran out of room on the front, so I'm going to have to put this on the back. So first of all, I want to reintroduce this idea of the reciprocal trigs. Could I fit that? Actually, we might be able to put that on here. So sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals of each other. Now we call these the reciprocal trig functions, but if cosecant is the reciprocal of sine, then logically sine must be the reciprocal of cosecant. So I'm going to add this onto the end of each one of these. Sine is the reciprocal of cosecant. That means that 1 over cosecant is the same as sine. And therefore, cosecant then is the same as 1 over sine. I'm going to run out of room, darn it. One of these years, I'm going to organize this thing in a way that everything fits perfectly, but I'm not there yet. So, cosine is the reciprocal of secant, and secant is the reciprocal of cosine. Tangent is the reciprocal of cotangent, and cotangent is the reciprocal of tangent. So the idea here is that if you've got a cosecant on the bottom of a fraction, you can move it to the top of the fraction and turn it into a sine. So you can reciprocal it and turn it into a different trig function. Like I said, this will make more sense as we do more examples. Some other things I just want to point out, I want to remind you of some notation here. So if I have something like sine squared, now there's no way to type sine squared of a number into your calc. Your calc would say that's crazy. Sine and then the squared and then let's say 30 degrees. It says syntax error. So this is a notation, this squared thing is a notation that mathematicians came up with to save themselves some work. So anytime we can come up with writing less symbols, that's what we do. We use that process. So let's add this. I guess I'm running out of room on the front, so I'll add this to the back. Sine of squared of x really means the quantity of sine of x getting squared. So that squared is really around the whole chunk, around the whole thing. This is not the same. Sine squared of x does not equal sine of x squared. Look at what that notation. Who's getting squared in the second equation? The x is, right? We don't want to just square the x. We want to make sure that we square the sine and the x. And then we also have these things called the Pythagorean identities. They're going to be there. There's 9 of them, so I'm trying to find a good spot to write. These are called the Pythagorean identities. All right, the first most famous Pythagorean identity is sine squared plus cosine squared equals 1. Okay, why does this work? So normally I do this on the board, but we don't have a board here. All I have is this camera. So I'm going to show you on this little piece of paper here. So let's say you're anywhere in the unit circle. and I go to any rotation, I'm just going to live in the first quadrant because it's easier. So here I am in the first quadrant. This is the x side of my triangle, but when we think of x as being cosine. So this length is the cosine side of my triangle. This length is the y side, but we know y and sine are the same thing. And then we also know that in the unit circle, the hypotenuse, because this is a rotation, this hypotenuse is going to be a length of 1. Now, what kind of triangle is this? This is a right triangle, which means we can apply the Pythagorean theorem. So a squared plus b squared equals c squared becomes cosine of x squared plus sine of x squared equals 1. And now we use this fancy notation so we don't have to write parentheses all the time, and we take the squared and we just put it on the cosine and put it on the sine. Now, I chose to write mine sine squared first. That's just the way that I memorized it. So you can write it however you want. You could put however you want, but you could put the cosine first if you wanted to, like I did in this example. Now, there are two other versions of this. There's the sine squared plus cosine squared equals 1. That's looking at it from the perspective of 1 being by itself. Well, I can rearrange so that sine squared is by itself by pushing this to the other side. So another way to look at this is to say that sine squared equals 1 minus cosine squared. Or, so now I've looked at it from the perspective of 1 being alone, of sine squared being alone. Let's go back to this one and get cosine squared by itself. So cosine squared of x equals 1 minus sine squared of x. All right, so this is one of the three Pythagorean identities with its two other perspectives or ways to look at it. Let's talk about then how do we generate the other two ways of looking at Pythagorean identities. Well, you're either going to divide by sine squared or you're going to divide by cosine squared. So let's take sine squared x plus cosine squared x equals 1. And let's divide that by cosine squared. So I'm going to divide each piece of this. Get a good color here. I guess I'll go with blue. Divide by cosine squared. Divide by cosine squared. And divide by cosine squared. So sine squared divided by cosine squared, we know from earlier, is the same as tangent. Now, because they were both squared, sine divided by cosine is tangent, but because they were both squared, that's going to become tangent squared. Cosine squared divided by cosine squared, anything divided by itself is 1. And 1 over cosine, now we just talked about this. This is my first chance to use this. 1 over cosine is the same as secant. So 1 over cosine squared is the same as secant squared. So another way to look at another Pythagorean identity is I'll go with this color, I guess, is tangent squared plus 1 is equal to secant squared. So tangent squared of x plus 1 equals secant squared of x. Now, there are two other versions of this. So in this case, I've got the secant squared by itself. I could also get the tangent squared by itself. So I'm going to bump over the 1. So tangent squared of x equals secant squared of x minus 1. Or I can go back to this one and I could bump over the tangent. So that would be 1 equals secant squared of x subtract tangent squared of x. Now, I went and took sine squared plus cosine squared equals 1 and divided by cosine. I could do it again, but instead of dividing by cosine, I'm going to divide by sine. So divide by sine squared, divide by sine squared, divide by sine squared. So sine squared divided by sine squared is 1. Cosine divided by sine is cotangent, but they're both squared, so that's going to become cotangent squared. And 1 over sine is cosecant. And so this is another Pythagorean identity. I mean, it's the same Pythagorean identity, just manipulated differently. So our third Pythagorean identity is 1 plus cotangent squared of x equals cosecant squared of x. And then I can look at that from two different perspectives. I can try to get the cotangent by itself. So cotangent squared of x equals cosecant squared of x minus 1. Or I could get the 1 by itself, which would be cosecant squared of x minus cotangent squared of x. All right, lots of stuff. I don't need you to memorize that. I don't need you to memorize those. I mean, it's kind of cool to understand how they work. I think that's worthwhile. But you don't have to memorize it. That's why you get to use the unit circle on tests. Okay, so simplifying trigonometric expressions. We're really trying to just clean this up until it gets down to one term, till it gets down to one piece. So there's not really, this is one of the frustrating things as a teacher. Sometimes you get these math lessons that you can't just say, it's not an algorithm to solve them. Like solving an equation in Algebra 1, that's an algorithmic process. I can say, do this first, then this first, then this next, then this next, then this next, and you'll be done. This is different. You just kind of have to follow your math voice. You have to just kind of look for the tricks and try to apply them. There's no set way to do it. So there are two tricks. These are the tricks. These are the things that I can at least give you a hint. Try these first. Number 1. And it doesn't even mean you have to do this first. I just write because there's 2 of them. 1, turn everything into sine or cosine. So that's one thing that you can start with. That's usually a good place to begin. It doesn't mean it always works, but that's a good place to begin. Number 2, look for Pythagorean identities. Now, what that really means is you look for squares. So if you see something with a squared on it, you're probably going to apply one of these identities. Doesn't mean you're going guaranteed to, but you're probably going to, because see, all these things have squares on them. So that's usually a hint. Okay, so let's take a look. Simplify cosecant of theta, sine of theta. So equals So I'm going to try this one first. I'm going to turn everything into sine or cosine. So cosecant is not a sine thing. I'm going to look up my identities. Cosecant is the same as 1 over sine. So I'm going to turn cosecant into 1 over sine. Times by sine is a sine thing, so I'm going to leave that the same. You'll notice that we have, now I have this thing, and then from here I'm just going to follow my math voice. I'm trying to multiply these two things. This is a fraction, this isn't, so I'm going to make it a fraction. When I multiply straight across, that's how you multiply fractions. You don't need a common denominator. I get 1 times sine is sine. I get sine times 1 is sine. Sine divided by sine is 1. I'm down to one term, so that's what we're going to consider for today. Tomorrow, or next time, I'll tell you where you're supposed to stop. But for now, just get it down to one piece and you're good to go. Notice a couple of things. I wrote everything out, and I included a variable after the trig functions. You can't just write sine without it. If you don't like using these Greek letters, then just use x every single time. I'm okay with that. But you've got to include some variable each time. All right, simplify 1 minus sine squared of alpha. All right, so what is our 2 hints? Turn things into sines or cosines. Well, that's already a sine or a cosine. And then look for squares. Look for Pythagorean identities. So I see I've got a squared here, and I'm going to refer now to my list. Do I have anything in here that says 1 minus sine squared? Yep, right there. 1 minus sine squared. So what I can do is I can substitute cosine squared in its place. So each one of these are like a puzzle. You're just trying to clean things up. You're trying to just, make it look a little bit nicer each time. All right, let's take a look. Secant squared beta minus 1. So this is one of those scenarios where, well, should I turn everything into sine or cosine, or should I look for a Pythagorean identity? It doesn't matter. You can pick. Let's say that you tried to look for, let's say you tried to turn everything into sine and cosine first. So if I went that route, so secant squared, secant's the same as 1 over cosine. So secant squared would be the same as 1 over cosine squared. Subtract 1. Okay, at the end of the day, this is a what? Fraction. If I want to subtract fractions, they have to have a common denominator. So I'm going to change 1 into something that would have a common denominator with cosine squared beta. Well, let's change it into cosine squared beta over cosine squared beta. Now, I've got a common, right? That's the same, that's equivalent to 1. I've got a common denominator. That means I can make this cosine squared beta. 1 minus cosine squared, I can't clean that up. So the best I can do is just rewrite that. 1 minus cosine squared beta equals, okay, I'm not down to one thing yet. I've got 3 different terms at this point. I'm trying to get down to just a single term. So 1 minus cosine squared, everything's in cosines and sines, but 1 minus cosine squared, that's my math voice saying, hey, that might be a Pythagorean identity. And if I look up, yep, 1 minus cosine squared is the same as sine squared. So I can now sub this out and put in sine squared in its place. What's sine over cosine? Tangent. So what's sine squared over cosine squared? That would be tangent squared. I'm down to one term. That's where we're going to stop for today. Now, let's say right off the bat, though, you look for squareds. Look how much quicker this is if you look at these. You don't just automatically do one or the other. You look at them and think about it first. Does this have a squared? Yes. I can look up, and if you see, I've already got a Pythagorean identity for secant squared minus 1. It's tangent squared. So I could have just been done. Secant squared minus 1 is the same as tangent squared. I'll get the same answer, but I get it a lot quicker. So you're not automatically doing one thing or the next. You're trying to think about this, and you're trying to listen to your math voice as you go through. All right, let's try cosine lambda, cosecant lambda. I'm going to encourage you to pause here. Try to do this one on your own. I don't see any squared, so I know I'm not going to use a Pythagorean identity right off the bat. So I'm going to try to turn things into sines and cosines. So that's cosine of lambda times cosecant's 1 over sine of lambda. If I want to multiply fractions, they both need to be fractions. Multiply top to top goes on top, so that's cosine of lambda over sine of lambda. Cosine over sine. Okay, sine over cosine is tangent, so cosine over sine must be cotangent. I'm down to one term. I've solved the puzzle. All right, let's start to get in where a couple other tricks, some other things that you might not recognize without somebody. I didn't recognize them without somebody showing me. All right, so the first one is this scenario. So I'm looking at this problem and I'm saying, okay, I see a squared and I see stuff that's not sine or cosine. So I'm going to do both moves at once, but I want to start with this one. As I look up, I see sine squared minus 1, and over here I see 1 minus sine squared. Whenever you see something that's backwards, I mean, think about it like this. What's 10 take away 3? 7. What's 3 take away 10? Negative 7. So I get the same answer, but they're off by a negative when I switch around the order of things subtracting. 10 subtract 3 is the opposite of 3 subtract 10. So when I have secant squared minus 1, that's going to be the opposite of 1 minus secant, or did I say secant? Sine squared minus 1 is going to be the opposite of 1 minus sine squared. So I'm going to leave a little note here. If things are backwards, that means that you're going to have a negative. Now, that's a little bit misleading because what if it's sine squared plus 1? Can you switch around a plus and get the same answer? What's 10 plus 3? What's 3 plus 10? So addition is what we call commutative. Subtraction is not commutative. Subtraction is off by a negative. So anyway, if I want to clean this up, sine squared minus 1 is going to be the opposite of, so 1 minus sine squared is cosine squared. Since that's backward, it's going to be the opposite of, well, let's do this the long way. So what I could also do, another way to think about it, is to factor out a negative. If I factor out a negative, then this negative 1 becomes the positive, and the sine squared becomes the negative delta. That's one way to do it if you want to. What I will usually do, I would skip this step right here, and I would just jump right from this, and I would say that's backwards, and it's supposed to be cosine squared, so I'm just going to make it negative cosine squared. Times, what do we know about secant? Secant is the reciprocal of cosine, so that becomes 1 over cosine. I've got a fraction times something else, so that something else must become a fraction as well. I would multiply straight across, so I would get negative cosine squared delta over cosine of delta, which means I could kill off one of the cosines, and I would get negative cosine of delta. All right, simplify cosecant of psi over secant of psi. Let's see. So there's two ways to do this. There's the long way and the short way. I'll show you the long way first. The long way is to turn each one of these into their reciprocal. So cosecant is 1 over sine over secant, which is 1 over cosine. Nobody in the world can divide fractions, so what do we do instead? Flip and multiply. So I'm going to take this, I'm going to multiply it up. I'm going to flip over that fraction, reciprocal, and we would get a cosine of psi on the top, of xi. I keep saying psi. I think it's xi. It's a better way to pronounce it. So you don't have to show that step if you don't want to. You can go directly from here. It is legal to go directly from here, to here. You can cut out that middleman because what did we say? A cosecant on the top is the same as a sine on the bottom. A secant on the bottom is the same as a cosine on the top. So you can skip that part if you want to. If not, it's not like it takes a long time to write that out. Cosine over sine, that's cotangent. I'm down to one term. Box it in, put it up on my fridge. All right, 1 minus cosecant squared of chi over cosine squared of chi. So, all right, so my math voice says, clean this up. So 1 minus cosecant squared makes me think of my Pythagorean identities. Here's the cosecants. Okay, I've got 1 minus cosecant squared. The Pythagorean identity is cosecant squared minus 1. So that's going to be the opposite of cotangent. So now I'm just going to switch this into negative cotangent squared of chi over cosine squared of chi. All right, now my math voice is saying, now look, by the way, sometimes you do want to switch the other direction. So sometimes you want to take cosine squared. See how that has a squared? You could take out that cosine squared and put in 1 minus sine squared. That is legal. But most of the time, we don't want to do that. I think 95% of the time or even higher, we don't want to switch one thing for two terms. Remember, our goal is to get it down to one piece. So if we have two pieces, that's usually worse. All right, so what can we do here? I don't want to trade these out because it'd go back to something bigger. Oh, cosine squared. Cosine squared is one of our cosine. I keep saying cosine. Cotangent. Cotangent is the same as cosine over sine. So negative cotangent squared would be negative cosine squared chi over sine squared chi over cosine squared chi. Nobody in the world can divide fractions. So what we do instead is we turn this into a fraction and flip and multiply. Flip and multiply. And now we can start to clean this up. All right, so let's see. Okay, this is kind of nice. I've got a cosine. You could multiply it all together if you want to, or you can cancel things out. Cosine squared over cosine squared is going to cancel out, but I still have this negative on the top, so that's negative 1 over, and then I still have a sine squared on the bottom. Can we go further than this? Yes, because cosec or sine squared is the same as, let me try again, a sine squared on the bottom is the same as a cosecant squared on the top. So this is going to be a negative cosecant squared of chi. All right, last but not least, simplify tangent of rho minus tangent squared of rho minus tangent squared of rho sine squared of rho. So in this one, yeah, you could try to turn these into sines and cosines. It would work. You could clean it up from there. But I want to show you a trick that we haven't talked about in a while, but you always should be alert for it. What do you notice both of these have? Both of these terms have a tangent, which means that we can factor out. Factor out any like terms. So these things both have a tangent squared. So I'm going to take out a tangent squared. That leaves behind, now don't forget, when you divide out a tangent squared, when I distribute it, I have to have something there. A lot of people think that that term is gone. That's incorrect because I have to have something to distribute to. So you're dividing each term by tangent squared. So what's tangent squared divided by tangent squared? 1. What's tangent squared sine squared divided by tangent squared? Negative sine squared. Okay, life is good here. I'm going to do a double move because I have two things that I'm noticing. I can turn this into sines and cosines, and I'm going to look this up as a Pythagorean identity. So tangent sine over cosine. So that would become sine squared over cosine squared times 1 minus sine squared, 1 minus sine squared, 1 minus sine squared is cosine squared. So times by cosine squared. This is a fraction, and this is not a fraction, so I need to make it into a fraction. How do you multiply fractions? Straight across, or you can look and see if things cancel first. Those cosine squareds cancel each other out, and we're left with sine squared. What do you think? All right, so pay attention. Look for that factor out thing. That's going to be one that you're only going to see a couple times, but you still got to be alert for it. Good luck.